Hello to everyone. Hello to everyone. In this video, let us go for which one NaOH preparation and properties of NaOH. And NaOH is also known as, that is sodium hydroxide, of course, that is also known as caustic soda, because when it fall on skin, that eats away the skin surface and make it pulp. So due to that action, this NaOH is known as caustic soda. Now let us see the preparation methods of NaOH. So first one is electrolysis method. Okay, in some books you can see this as Nelson cell method, but simply that is called as electrolysis method. In this electrolysis method, brine solution taken as an electrolyte. Brine solution means which one? 10% NaCl solution. 10% NaCl solution is known as a brine solution. That means the remaining 90% is nothing but water. So this is taken as electrolyte. And in this, which one here? Graphite rod acts as anode. Graphite rod acts as anode, and perforated steel vessel. Perforated steel vessel acts as which one? Cathode. Now, in the electrolysis process, brine solution undergoes electrolysis to give which one? Na plus and Cl minus ions. Now, at anode, these Cl minus ions will oxidize to liberate chlorine. And at cathode, so here at cathode, instead of this Na plus ions, that water undergoes electrolysis. So now water on electrolysis will give OH minus and hydrogen gas. Now the Na plus formed in this electrolysis and OH minus formed here combine to give NaOH. Okay, like this we can prepare which one? NaOH by electrolysis method. And this is the beneficiary method, because the byproducts of this method are which one here? Chlorine and hydrogen gas. We know that hydrogen gas is most important for industrial, that is used as a fuel. So this is a beneficiary method to prepare which one? Sodium hydroxide. This is electrolysis method, or we can say that as Nelson cell method. And another method is also there. What is that here? Means Kastner Kellner method. This is another method to prepare which one here? So that means sodium hydroxide. In Kastner Kellner method, we need that description of that electrolytic cell also here. What is that here? This, in this we are using a rectangular iron tank that is divided into 3 compartments. Now this is rectangular vessel divided into 3 compartments using 2 slate partitions, and into the outer compartments we have to take which one here? Brine solution. Into the outer compartments brine solution should be taken. Into the middle compartment we have to take which one? Dilute NaOH. So actually we want to prepare NaOH only, but again we are taking dilute NaOH in the middle compartment. So what is the role of this dilute NaOH? Means that act as a seeding agent. That means that can direct the reactions of this electrolysis process towards the formation of NaOH. So like that, this dilute NaOH acts as which one? Seeding agent. And also, if only pure water we have taken, we know that pure water is electrical insulator. So to make that to make that pure water as electrical conductor, a little amount of NaOH is added. So two reasons for that why dilute NaOH is taken in middle compartment. Okay, then into the outer compartments, graphite rods are suspended. So the graphite rods suspended into the outer compartments act as which one? Anode. They act as anode. And into the middle compartment, a bunch of iron rods are used. They can act as which one? Cathode. Okay, now the bottom layer of this container is covered with which one? Means mercury, and this mercury is having a specific name in this that can act as intermediate electrode. Why it is called intermediate electrode? See here, in the outer compartments graphite act as anode, but this mercury act as cathode. And in the middle compartment, iron rods act as cathode, but this mercury acts as anode. That means mercury playing two different roles. In outer compartments, that is acting as which one? Cathode. In middle compartment, that mercury acting as anode. So like that here, that as acting as both anode and cathode, mercury is known as intermediate electrode. So now in competitive exams, we get the questions like this. What are the questions? In the preparation of NaOH by Kastner Kellner method, outer compartments are filled with which one? Means a brine solution. Middle compartment filled with dilute NaOH, and that act as which one? Seeding agent, and made that pure water as electrical conductor. And outer compartments in that which acts as anode, graphite rods act as anode. And in the middle compartment which acts as cathode, they give the question iron, bunch of iron rods. And regarding mercury also we get the questions. What is the role of mercury in outer compartments in Kastner Kellner method? Means that play the role of cathode in outer compartments, but in the middle compartment mercury play the role of which one? Anode. And here at the bottom one eccentric wheel is present, that is used to which one here? To bring this mercury, or to move the mercury in entire three apartments. So in the inter three compartments, to move that mercury in the three compartments, we have to use which one here? Eccentric wheel. So with the help of eccentric wheel, that mercury made to move in entire that three compartments. So like that, this is the construction of a Kastner Kellner cell. Now let us see what are the reactions taking place here in outer compartments. In outer compartments, what are the reactions taking place here? Means NaCl undergoes electrolysis to give Na plus and Cl minus ions. As in the case of electrolysis method, like that only here also, that NaCl present in outer compartments that undergoes electrolysis to give which one and which one here? Na plus ions and Cl minus ions. Now as usual, these Cl minus ions move towards anode, and which gas is liberated? Means chlorine gas. Now that means here what is the product liberated from outer compartments? Also they may give the question. Chlorine is the product liberating out from outer compartments. Now at mercury cathode, because in outer compartments mercury acts as a cathode. Now these Na plus ions move towards mercury cathode and they form sodium amalgam. So now by using this eccentric wheel, this sodium amalgam should be brought into middle compartment. So now the reactions we have to see in which one, middle compartment. So in the middle compartment, mercury play the role of anode. So we have to say here at mercury anode. The above reaction takes place in reverse direction. That means sodium amalgam will give Na plus and electrons and mercury. And at cathode, water present in dilute NaOH undergoes reduction to give which one, OH minus ions and hydrogen gas. So from the middle compartment, what is the gas liberating out means hydrogen gas. Those are also important questions. What are the byproducts from outer compartments and middle compartment in Kastner Kellner method? Now finally here, Na plus ions combine with OH minus ions and they give which one, concentrated NaOH. So this is regarding which one, NaOH preparation by Kastner Kellner method. Okay, these are the preparation methods of which one here, NaOH. And properties of NaOH means here, NaOH is which one here, colorless and transparent solid. That means that is present in solid state but colorless, no color is there. And it is of course highly soluble in water. That NaOH is highly soluble in water and that is having hygroscopic nature. That means that absorb moisture and also CO2 from atmospheric air. Okay, now let us see the chemical properties of NaOH. So as NaOH is having basic nature that reacts with which one, acids. So let us see reaction with acid. It is very easy. NaOH plus HCl, what we can get here, NaCl plus water. And NaOH reacts with metals also. With metals means here NaOH react with zinc, aluminium and also with beryllium, and that causes which one here, liberation of hydrogen gas. Of course here we can get sodium zincate, sodium aluminate like that, but the major product is which one, main we have to concentrate on. What is the main product of this reaction means hydrogen gas. So like that NaOH reacts with metals and liberate which one here, hydrogen gas. Now reaction of non-metals are with NaOH. So what is the reaction of NaOH with non-metals? In that especially fluorine we have to consider here. NaOH when treated with cold and dilute NaOH, what is the major product means here, OF2 is the major product, we have to concentrate on it. So when that fluorine react with cold and dilute NaOH, when fluorine react with cold and dilute NaOH, what is the product here means OF2, oxygen difluoride. But when hot and concentrated NaOH, when hot and concentrated NaOH react with fluorine, instead of OF2, we get here which one means oxygen. So this question we get in competitive exams. When fluorine react with cold and dilute NaOH, what is the product means we have to give the answer, oxygen difluoride. And if hot and concentrated NaOH react with fluorine, what is the product means our answer should be oxygen. Now remaining halogens, that means chlorine, bromine, etc., what they give the products, let us see here. Cold and dilute NaOH when treated with chlorine, what is the product here means NaCl plus NaOCl plus H2O. So we can get which one here? Sodium hypochlorite. Sodium hypochlorite. In this reaction, chlorine oxidation state changes from 0 to -1 and here 0 to +1. So this reaction is an example of disproportionation reaction, because for the same element we are observing change in oxidation number here. That means that is undergoing both oxidation and reduction. If the same element undergoes both oxidation and reduction, that is said to be disproportionation reaction. So now here we are getting sodium hypochlorite. If we consider hot and concentrated NaOH, so now here what is the product? We can get NaCl common, but here we are getting sodium chlorate. Sodium chlorate formula NaClO3. Here also oxidation number changes from 0 to -1 and 0 to +5. That means it is also an example of disproportionation reaction. So like that here, except fluorine, remaining chlorine or bromine will give the products like this with NaOH. So this is the reaction of NaOH with non-metals. Okay, then after that here NaOH react with silica also. Silica means nothing but which one? SiO2, and produces which one here? Silica glass. Na2SiO3. Sodium silicate is known as silica glass. So like that NaOH react with SiO2 and produces which one? Sodium silicate known as silica glass. So like that here NaOH will give the product with which one? SiO2. Okay, now reaction with phosphorus. So in non-metals, another reaction here, reaction with phosphorus and sodium, that means phosphorus react with dilute solution of NaOH and produces Na2HPO, okay, Na2HPO4 plus which one here? PH3 phosphide. So this is also come under which one here? Here this is reduction, this is oxidation. So like that here phosphorus undergoes a disproportionation reaction to give which one? Phosphine and sodium hypophosphite. So this is the reaction of phosphorus with which one? Means here NaOH. So these are the chemical properties of NaOH. Okay. In our next class, let us go for which one here? Means sodium carbonate, Na2CO3, its preparation and properties.